Hey everyone, welcome back to the channel. In today's SOLIDWORKS tutorial, we are going to design a complete heat exchanger assembly from scratch. You will learn how to create the copper tube path and return bands, build cooling fins and assemble everything into a realistic heat exchanger mode. If you are interested in mechanical design or HVAC components, this tutorial is perfect for you. So let's get started. Before we begin, let's aim for 50 likes on this video. This is our part number 1. Select front plane, select a top plane, draw a sketch, create a circle and the circle diameter will be 10 mm. Now go to the front plane, create a path for the pipe, extend this line around 34 mm, exit the sketch, create a fillet and the fillet radius will be 12.65 mm and OK. Now we will define the sketch fully. The length of vertical line is 10 mm and also this line 50 mm and the horizontal will be 62 mm. Now our sketch is fully defined. We will use swept bars. Go to features, select swept, profile will be this and the path will be this and OK. Now I am going to use edit appearances. On this one will be copper. I am going to select polished copper and OK. Select this face. Convert entity, exit the sketch, right plane, select 3-point arc, draw a arc here like this, create a line and both must be in a tangent position. Perfect. And the radius of this arc will be 12.65 mm and the horizontal line will be 26 mm. And this point must be in a horizontal position. So our sketch is fully defined. We will use again the repeat command. The sketch profile will be this and the path will be this. Make sure merge result is checked. Now we will use shell feature. The shell parameter will be 0.5 mm. Select both the faces and OK. As you can see, the inner diameter will be 10 mm and the outer one will be inner will be 9 mm and outer will be 10 mm. Let's save this part. I'm going to create a new folder here and rename it as heat exchanger. OK, and the part name we have to save pipe 01 and OK. So this is our part number 1 is created. Now we will create part number 2. Open the part number 1, edit the sketch swept to select this sketch number 5. This one I'm going to re-edit 48 mm, exit the sketch, and let's save this part as save as this part. This is pipe number 2. Okay, our part number 2 is created. This will be our part number 3. Select front plane and the diameter will be 10 mm. Go to feature, extrude boss, mid plane, and the depth will be 291. Select shell and the 0.5 mm. Select part, edit appearances, copper. I'm going to select polished copper or brushed copper, so it looks good. So let's save this part number 3, pipe 03. This will be our part number 4. Select top plane, draw a sketch here. The diameter will be 10. Front plane, select 3-point arc, draw an arc here like this. This point and that point, make it horizontal, and the radius will be 12.5 mm. Make it horizontal and exit the sketch. Swept boss. This is a C type and the shell 0.5 mm. Select edit appearances, copper and brushed copper, and OK. We will save this part, the name as, this will be pipe 04 C type. This will be our part number 5. Select front plane, draw a corner rectangle. The vertical line will be 210 mm and the horizontal one will be 44 mm. Okay, go to features, extrude, the depth will be 0.5 mm, and OK. Select this face and create a sketch. I'm going to draw a 2 circle here, both circle diameter 10 mm. Select both and equal. Let's define the vertical dimension 10 mm and this distance, this point to that point, 12.5 mm. Select both point and angled dimension will be 25. Draw a construction line like this. It's better to delete this, extend this construction line, make it construction geometry, still moving. Select this midpoint and this upper midpoint, make it joint and make it vertical. Our sketch is select extrude cut and OK. Again select this face, draw a sketch here, convert entity, offset it, select both circle and the 0.5 mm, go to extrude and the depth will be 4.5 mm and OK. I'm going to use linear pattern. Select this, the features will be this one and the cut extrude, and the spacing will be 25 and I want 8 number of instances. OK. Here we need a fillet, so select these two and create a fillet of 0.5 mm and drag this, move upward direction and select this fillet. So our sketch fillet also in a linear pattern. This is the last step for this part. Draw a circle here and the circle diameter is 6.2 mm. Draw a line like this and both must be in a construction geometry as well as vertical and horizontal. So our sketch is fully defined. Same way we need a circle here. Make it horizontal. Both must be in a construction geometry. Still not fully defined, and make it the diameter of this circle 6.2 mm. Extrude cut and OK. This is our part number 5 is ready. This is cooling plate 05, 5th number. I have made a mistake, so save part number 5 as cooling plate. In the next step we will create a part number 6. Select front plane. I am going to design a plate 210 mm and the horizontal will be 44 mm. Select base flange and the thickness of the plate is 0.5 mm and OK. Select this face, draw a sketch, create a 2 circle, both must be equal. Select this point and that point, the distance is 25 mm and this one 10 mm and the vertical will be 12.5 mm. Draw a line like this, both must be construction geometry and hit the green check. The center point of this line to that line make vertical. This one is construction geometry, or you can say like a symmetry, and the circle of the diameter is 10 mm. Go to cut extrude and OK. Now we have removed the material. In the next step we will use linear pattern. Select cut extrude as well as this circle Go to sheet metal. We will use a flange here. Select this edge and the material must be outside, and the flange length is 10 mm, and uncheck the use default radius, and this radius is 0.05 mm. Here I need two holes, so I'm going to create a hole here. Select hole, select ISO. This one will be drill sizes, and the drill sizes I'm going to define 7. And condition we don't have to decide. Create a hole here, and another one is here. Escape button, and the distance of this dot point will be 10 mm, and the horizontal distance is 8 mm. Same way we have to apply on the upper side, 10 mm and 8 mm. Hit the green check, exit the sketch. Now I'm going to use a brick corner or chamfer here, not fillets. Select chamfer. The chamfer will be 2 mm. Select this edge and that edge, not a face. Now apply edit appearances. This one is brushed steel, and the color I'm going to use red. Here if I select flatten, it will flatten. It means it generates a DXF file for laser cutting. This one, part number 6, SS and plate 06. This is part number 7. We will modify the previous sketch, SS and plate 6. Open this part. Select each flange 1 and reverse the direction of the flange length. Let's re-edit the hole here. Go to position, normal to. Here instead of 8 I'm going to use a negative sign. Again use a negative 10. Same thing we have to apply on the opposite direction, negative 8. And negative 10. Let's save as this one as 67.ss and plate number 2 and 07. Let's create part number 8, and the file name of the part will be 8 dot support rod 08 and save. Select front plane, draw a circle here, and the circle diameter will be 6, and the depth will be, select mid plane, to 2.5 mm and OK. This will be our support rod for the heat exchanger, and the chamfer is 0.5 mm. Select both the faces and OK. Now we will apply the material. Select this part, go to appearances. I'm going to select metal, not a plastic. Select polished steel or polished aluminum. In the next step, we need to modify this part number 6. Select this face. I'm going to create a circle here. This point to that point, the vertical distance is 12.5 mm, and this circle will be 6.2 mm. To fully define the sketch, we need to create a 2 lines and make it construction geometry as well as vertical one. Same thing, we have to define the bottom one. Follow the step I have made. Now we need to save this part number 6 as SS and plate 06. Use the shortcut key Ctrl S and OK. Again I am going to open another part, SS and plates 2. Here also I need 2 holes. Select this face, draw a circle here. And the circle diameter will be 6.2 mm. Make it vertical line as well as horizontal line. Make it construction geometry, and this distance is 12.5 mm. And the bottom one I'm going to define as a 12.5 mm. This line, make it vertical, construction geometry, and select S key, cut extrude and OK. Use a shortcut key as Ctrl S. Once the all part has been created, we will assemble them one by one. Select part number 6 as a split 06, make it float and rotate it like this. Perfect. Hole, there are 3 holes, must be in a horizontal position. Select this face and that face, make it concentric relation. This is part number 8 we have imported, and make it coincident. Again I'm going to open the pipe make it concentric, drag this pipe like this. Now open C type pipe, rotate it, okay, select this face and that face. I'm going to use a distance mate and the distance is 3 mm. Select this face and this circle, make it concentric, still moving. Select this face and carefully select this face, make it coincident relation. So this pipe is joint. By using the control key, copy this part, select this face and that face, make it concentric relation, drag this pipe, select this edge and this face, make it coincident, still moving. Select this face and that face, make it coincident relation. So our assembly is fully defined. In the next step, we will open the part number 7 and plate 2 SS. Rotate it like this. And OK. Select this face and that face, make it concentric relation, select this face and that face, make it concentric relation, still moving. We are going to use a coincident relation here. Copy this C section by using a control key. Let's apply mate here. Select this edge and this edge, make it coincident relation and reverse the direction. Select this face and that face, make it coincident, okay. Select this face and that edge must be concentric relation. Later we will use a linear pattern. I am going to select a linear pattern. Select this edge and the spacing I'm going to use 25 mm and how many instances I want? 8. So there are 8 pipes and 8 C section. Select this pipe and this C section as well. And this. Okay. In the next step, we will insert the part number 5, cooling plate 05. Rotate it on the opposite direction. Select this face and that face, make it concentric relation. select this face and this support rod, make it concentric relation. Okay, let's fix this plate number 1. In the next step we will apply distance mate both, and the distance will be 5 mm. Again select a linear pattern. I'm going to linear this, select this edge. I want this direction. Number of instances, the distance will be 5 mm and 55. I want component will be this, and OK. In the next step, insert the component pipe number 1, rotate it like this. The bottom section on the opposite direction of the heat exchanger. Select this face and that face, make it concentric relation. Select this face and that face, make it coincident relation. As you can see, our part is rotating. So let's fix this. Select front plane of the pipe and the top plane. No, it shows error. Undo this. Go to mate section and delete this relation we have created recently. What I will do, expand this pipe 1 part, this front plane and that face, make it parallel. So our part is fixed. Open the pipe number 2. Insert this component in the assembly section. In the bottom, I am going to hide this part or suppress it. I am suppressing this part. Insert the pipe number 2. Rotate it. The part must be rotate like this. Okay, select this face and that face, make it concentric relation. Drag this part. Select this face and that face, make it coincident relation. Select front plane and this face, make it parallel. Why our sketch is assembly overdefined? Because C section we have suppressed. So that's it guys for this tutorial. If you enjoyed this tutorial, please hit the like button. Even if you found this tutorial helpful. Don't forget to like this video, subscribe to the channel and turn on notification. Thanks for watching. I'll see you in the next tutorial.